Here is the sixth behavioral design pattern, and this one is called Memento Pattern. It is a pattern you use when you need to capture and externalize an object's internal state, so that the object can be restored to this state later. I'll start with a quick summary of what we are trying to accomplish with this pattern. The Memento pattern is a good choice when you are trying to accomplish the following. You want to capture an object's internal state, so that the object can be returned to this state later. You want to externalize the object's internal state in a safe manner. You want to promote undo or restore functionality to full object status. Okay, let's go through these points one by one. In this pattern, I am working with one or more objects with internal state. In the terminology of the pattern, these objects are called the originators. The state information is private to the originator and must not be readable or writable by any other object. However, this poses a problem if I want to implement an undo or restore operation. An application architecture with undo capability needs to keep a history list of all prior object states. The history list is owned by another object, called the caretaker. So, to implement the undo operation, the caretaker needs to look up the corresponding state record in the history table and then apply it to the originator object. But how do I do that if the object state is private and can only be accessed by the originator itself? The memento pattern solves this problem. A memento is a kind of wrapper that encapsulates the state information and makes it suitable for export. A memento's internal state can only be accessed by the originator, but the memento object itself can be freely passed on to the caretaker object. This pattern allows you to read and update the state of the originator without making this state publicly visible throughout your entire application architecture. The benefits of the memento pattern is that it provides a generic way to capture object state and store it somewhere else. The memento wraps the object state information and makes it suitable for export, but it also protects the state information by ensuring that only the originator can access it. The memento object can now be stored in an undo list or a history table, without the caretaker object requiring any knowledge about the state information itself. The memento acts as a black box that perfectly encapsulates a single state record. You can undo the originator to a previous state by handing the memento back to the originator. The originator will then crack open the memento object, extract the internal state, and load it to implement the restore. Here is the UML diagram of the memento pattern. There are three classes participating in the memento pattern. The originator, which is the object with internal state. The caretaker, which is the object that controls when state is saved and restored. And the memento, which is the state wrapper that is read and written by the originator and handled by the caretaker. So let's start with the originator. The originator has private state, represented in the UML diagram with the private field called state. There are also two methods: create memento for creating a new memento instance containing the current state, and set memento for restoring the state by using the provided memento instance. The memento class also has a private state field, which contains a snapshot of the originator state at the time the memento was created. There are also two getState and setState methods. The originator uses these methods to initialize a new memento or read the state from an existing memento. And finally, we have the caretaker object. This can basically be any object that needs to hold on to state information. The object has a reference to one or more memento instances and calls the setMemento method of the originator object whenever a restore needs to occur. I am going to implement the memento pattern by creating a simple document editor. My editor supports text input and a few basic HTML formatting operations. There is also a separate object called document history that maintains a complete history of the document and supports a restore operation. I will implement the pattern with these classes. Okay, let's take a look at the code. I will start with the document class. You can see here that it is a class with a protected string field called HTML. This field will contain the full HTML text of the document contents. And here are a couple of methods for manipulating the content of the document. There's an append method for appending text to the document. There's an italic method that lets you format the entire document in italics. And there is a bold method that lets you format the entire document in bold. And down here are the memento methods. The saveState method captures the current state of the document, wraps it in a new document state instance, and returns the instance. So this is my memento object. The complementary loadState method does the opposite. It receives a document state instance in this parameter, extracts the state information from this memento, and assigns it to the HTML field. And this effectively implements a restore operation. And here is the document state class, which acts as the memento object. It's a very simple object with a single string field here, which contains a snapshot of the document state. There's also a public property here called state, which the document class can use to read the state information. But did you notice the cool trick I used? Look here. The saveState method creates a new memento object, but it returns the object as an object type. And the document state class here is actually embedded inside the document class. And it's a private class too. What's going on here? Well, this neat little trick makes the memento completely unreadable to the outside world. By making the document state class private and local to document, I ensure that it can only be accessed from inside the document object itself. So now save method must return the memento as an untyped object, because the outside world cannot access the document state class declaration. So nobody except document can cast the memento back to a document state instance. Okay, now let's take a look at the document history class. You can see here that it contains a list called, history, that contains the current and all preceding document states. There's a snapshot method here that creates a memento of the current document state and stores it in the history list. And this restore method here restores the document to a specific state. You simply provide the index number of the history list record, and the object performs the restore to that specific state. And finally, here is the main program method. I start by initializing a new document, filling it with text, and then performing italic and bold formatting operations on the text. You can see that I call the snapshot method after each operation to fill the history list. Then I restore the document to history record 1, which will bring it back to unformatted text. But then I do another restore to history record 2, and this brings the document one step forward to italic text. Let me run the program to prove that everything is working. I'm compiling the code now. And now I'm running the program. Here we go. And there you have it. First I get unformatted text, and then I get the italic text. Everything works. Okay, here is a quick checklist you can use to implement the Memento pattern. First, identify the originator class that needs to save and restore state. Then, identify the caretaker class that needs to control when state is saved and restored. Create a Memento class with encapsulated state information. Add create memento and set memento methods to the originator class. And finally, have the caretaker take snapshots of the originator and invoke restore operations. And here are some final comments. The biggest issue with this design pattern is how to ensure that the encapsulated state information in the Memento class can only be read by the originator class. In C++, you would use the friend keyword, but unfortunately C# has no direct equivalent. However, there are a couple of strategies you can use to shield access to the state information. You can use the same trick I used in the example. You make the Memento class a private subclass of the originator, and have the originator return Memento instances as untyped objects. The caretaker will now not be able to cast the Memento, because it cannot access the private Memento class declaration. If you don't like nesting classes, then you can also make the Memento class internal. If the caretaker resides in another .NET assembly, it will not be able to access the internal Memento class declaration. You often see the command and memento patterns used together. A command can use a memento to maintain the state required for performing an undo operation. And finally, memento is often used together with iterator. An iterator can use a memento to capture the state of an iteration. The iterator stores the memento internally. Okay, so here is a summary of everything that we have learned in this lecture. The memento pattern lets you capture an object's internal state, so that it can later be restored to this state. The pattern provides a generic way to capture object state and store it somewhere else. You can either nest the memento class or make it internal to protect its contents. The memento pattern is often combined with the command and iterator patterns.